Application modernization is crucial for successful cloud adoption. Many teams consider turning their applications into fast, scalable, and secure systems, as their legacy solutions are running slow and outdated. But they face significant challenges down the road. Where to start? What are the most critical steps? How could I achieve the most significant impact with limited time and budget? This is exactly what I will talk about today. In this first episode, I will provide a comprehensive overview of the various aspects of application modernization and cover those in the upcoming episodes separately using a small Java backend monolith application I developed especially for this series. It is like the veterinary horse used as a teaching tool in medicine. Practically, all imaginable faults and deficiencies are present in one single specimen. My application has exactly the same purpose. It contains all possible anti-patterns, poor development practices, and old and outdated techniques. I named it Béla. Béla is a traditional Hungarian name that once was very popular, but has become unpopular nowadays. Sorry for all the Béla. So our goal is to turn and refactor our traditional application, Béla, into a modern microservice-based architecture. Let's call it Neo. Our journey begins with understanding how to split our monolithic Java application into microservices. This process allows us to decompose the monolith into smaller, independently deployable units that can be efficiently managed and scaled. By the way, decoupling into microservices means splitting the database as well. Each microservice requires its own database to ensure scalability. We will discover techniques like domain-driven design and architecture patterns like event sourcing and CQRS, command and query responsibility segregation. Many years ago, the database was the center of everything, at least in software design. There were architecture diagrams with a database in the middle covering 80% of the space, and all the other critical components in architecture were represented as small dots like supplementary elements. One consequence was the rising army of stored procedures. Developers started implementing various business logic in the database, claiming this is the best practice and the most performant solution for many problems. As a result, databases turned into a single point of failure and the most common performance bottleneck recently. Next, we will explore the complexities of moving database logic into the Java application layer. This transition not only enhances performance but also simplifies maintenance and scalability. Number 3. The stateless architecture. States are obstacles. We have to remove them. Here is why. Your microservices will have multiple instances of each. In a long multi-step transaction, there is no guarantee that the same instance will be responsible for the entire process. Just imagine, you start filling out a long credit application form. You give your name, phone number, click next, and the software crashes. What happened? Between the two sections of the form, different service instances were involved. The first one defined a state about your personal information, which was unavailable for the other instance. This led to data inconsistency. Popular design patterns like Singleton can cause similar problems. So we will review how to identify these states and what are the possible workarounds or long-term solutions to support scalability. Number 4. Configuration management. Managing parameters and configuration files can be challenging in a distributed environment because in this architecture everything will be amplified. The number of microservices and their instances will multiply the required effort for maintaining and changing parameters and configuration files. All techniques like storing all config files per environment in the application source code do not work anymore. Enable dynamic configuration for microservices to adapt to different environment and scaling requirements. Externalizing configuration simplifies deployment by allowing each instance to retrieve specific configurations dynamically. I will show you how to externalize parameters and config files effectively. Number 5. Messaging queues. Communications between microservices is essential. We will dive into how to integrate microservices using messaging queues for reliable and asynchronous communication. Messaging queues facilitate asynchronous communication between microservices, enhancing scalability and fault tolerance. We delve into the implementation of message brokers like Apache Kafka or RabbitMQ, showcasing how they enable decoupled event-driven communication. You will learn how to design resilient message queues, handle message retries, and ensure reliable message delivery. Additionally, we address message serialization and versioning to maintain compatibility as your microservices evolve. By mastering messaging queues, you will establish a robust communication for your modernized application. Number 6, code quality. These sections delves into two crucial aspects of app modernization: test-driven development and clean code practices. TDD involves writing tests before writing the actual code, ensuring that your microservices meet functional requirements while maintaining stability during updates. We guide you through the TDD process, emphasizing the creation of meaningful unit tests and the use of testing frameworks. Clean code principles, on the other hand, focus on writing code that is readable, maintainable, and free of technical depths. We will discuss code organization, naming conventions, and the solid principles to create code that is easy to understand and modify. By adopting TDD and clean code practices, your modernized application will benefit from the increased reliability, maintainability, and scalability, ensuring it remains robust and efficient as it evolves in a microservice-based architecture. Number 7, security. First, we explore authentication and authorization, ensuring that only authorized users access your microservices. Next, we delve into API security, API keys, OAuth2, and JWT, etc. for secure data exchange between microservices. Data encryption is also crucial, especially for handling sensitive information in your data layer. These foundational security practices establish a robust security framework for your cloud-native application, ensuring data protection and controlled access. Number 8, logging and monitoring. Address cross-cutting concerns like logging and monitoring within the context of cloud-native architecture is a separate topic its own. Distributed tracing is a technique that addresses logging information in microservice-based applications. A unique transaction ID is used throughout each transaction among all microservices involved to capture user activities end-to-end. Besides its traditional function like gaining real-time insights into your application's performance and health, monitoring is also responsible for triggering auto-scalability. Number 9, containerization. Finally, with all the tedious modernization steps, we have a bunch of fresh new microservices running in a complex environment with multiple instances of each. Maintaining, deploying, and versioning them is no longer possible with traditional manual way. Containerization is a fundamental step toward achieving portability and scalability. We will guide you through the process of containerizing your application and leveraging container orchestration framework like Kubernetes. Number 10, service mesh, advanced topic. Lastly, we explore the benefits of adopting cloud-native architecture components like service mesh. Service mesh is a dedicated infrastructure layer that handles service-to-service communication, offering advanced capabilities for reliability, observability, and traffic management. We will dive into technologies like Istio and showcase how service mesh simplifies the complexity of microservices communication. So, if you are ready to embark on this modernization journey with us, stay tuned for our upcoming episodes. We will provide practical insights, tips, and hands-on demonstrations to help you modernize your Java application into a cloud-native masterpiece.